Hello, everyone. Welcome back to the St. Pete Science Festival. Today we have Dr. Tracey with us from NOAA, and she is going to talk about lots of science stuff and red tide particularly. So thank you, Dr. Tracey, for being here today, and I will hand it off to you. Remember, folks, to put questions in the chat as we go, and we will have time at the end for Dr. Tracey to answer those.
Hey everybody, my name is Dr. Tracey Fanara. I am going to share my screen right now. All right. Can everybody see my screen? Yes? Okay, let's hope that's a yes. So, hi everybody, I'm going to teach you how to save the world today. So everybody always says to start with why, like what you're passionate about, to get people excited about what you're talking about. And for me, my journey to where I am right now comes back to two main moments. One was in 4th grade, a teacher told me about this hazardous waste dump site around where I grew up, where industries were dumping toxins into canalways, and those toxins were getting into the soil and the groundwater, and people started getting sick. And that's when I realized that everything in this world is connected. What we put into the environment eventually comes back to affect our health. This incident was called Love Canal, and it started the Environmental Protection Agency's Superfund program. So that's a program that cleans up hazardous waste sites that are threatening human health. But then when I learned that unsafe drinking water was the leading killer worldwide among children, that's when I really knew that I had to do something. I had to do something whether I was paid for it or not, something that we take for granted. We just turn on our faucets and have clean water, to learn that people around the world didn't have that same thing, and how much we take for granted. That's when I realized that I found my true passion. And so I heard about this career where I can provide clean water and food and clean air and protect people from natural disasters and build and design things. And I was like, I want to be a superhero. So I became an environmental engineer. But I realized while I was going through school that there was so much that people around me didn't know about how the world works. I realized that my friends were throwing garbage out their car windows, and I asked them where they thought that went, and either they didn't know or they thought it went to a wastewater treatment plant where that garbage would be removed or cleaned up. In fact, every single drop of rain that lands in the state of Florida and most of the US goes right to our natural water bodies with all of that garbage on the ground with it. And so upon telling my friends, I realized that their behaviors changed. I noticed that they stopped throwing their trash out the car window or on the ground. And I was like, wow, this is where I can really make a difference, is through education. So my parents were buying bottled water all the time. And I don't know if you guys know how much plastic and oil and how much transportation and fossil fuels are used in bottled water. And there's so much more to that. But my parents were buying it by the case. And I kept on telling them all the impacts, how bottled water doesn't have better water quality than their tap water, and nothing worked. Nothing worked at all. And I don't know if you've ever tried to change your parents' mind. It's tough. But I was just about to give up when I finally bought them a Brita filter, which is a water pitcher that filters out the water, and they love the taste of it. And I realized that I had to be creative with changing the world. So I realized communication was really important in science, and combining art and science was really important. So my research was on doing artful design strategies to clean water and preserve our ecosystems as they are. And then I realized that animals were basically a gateway science. People love animals. I love animals. And focusing on animals and protecting animals is a good way to get people to get involved with their environment and preserving their ecosystem. And so from there, I did a kids show, and I've done a bunch of TV shows from there just because of that education component. And I have a comic book that follows kind of my real life, but makes it a lot cooler in a comic book, called Seekers of Science. So I had to graduate college with my PhD, and I was going into the real world. And I took the job that paid me less because I felt like it had the most impact potential. It allowed me to do that communication and education along with scientific research. But what I didn't realize is that my program had been historically focused on a microscopic algae species. And I was used to doing big picture projects, worldwide projects. And I was supposed to focus on a microscopic species in the Gulf of Mexico called Karenia brevis. When these species are in big concentrations, meaning that they multiply like crazy, this is called a Florida red tide bloom. And we have a lot of problems in Florida, and Florida red tide is one of them. This is a native species. As far as we know, it's been around for hundreds of years. These blooms start offshore at the ocean bottom, which is super interesting. And the reason for that is that this microscopic species is a slow grower, meaning that they're outcompeted by other species close to shore. So they have to grow and get their nutrients offshore, but they're not picky eaters. So they can eat a lot of different forms of nutrients like nitrogen and phosphorus. Now, Florida red tide, or Karenia brevis, is a species of phytoplankton. That's a plant-like organism, and photosynthetic, meaning that it uses sunlight to make food along with nutrients. But there's phytoplankton all over the world. There's things called red tide all over the world. And in fact, phytoplankton over millennia has provided almost 70% of the oxygen that we have today. But some of those species are actually toxic, meaning that they release a toxin that harms aquatic life. And Florida red tide, or Karenia brevis, is one of those species. But what makes it so unique is that the toxin not only harms aquatic life, but it can also go up into the atmosphere, attach onto particles in the air, and move on shore with winds, causing people to cough or sneeze. And for those with asthma or COPD, this can be really serious. So these are some of the effects of Florida red tide. You might see water discoloration. You might see a lot of dead fish, manatees, sea turtles, dolphins, even sharks are impacted by Florida red tide. Now, this species, although there are things called red tide all over the world, Florida red tide is specific to the species Karenia brevis, like I talked about earlier, and is only in the Gulf of Mexico. About 9 times in the past, our currents in the Gulf of Mexico has taken those cells that bloom and brought it up the east coast of Florida, along the east coast, but it's mainly in the Gulf of Mexico. So in 2018, we had a really bad bloom, and you can see it right here. You can see how dark that water is. And there was a lot of chaos. It caused economic disaster, tourism problems, public health and recreation problems. If you guys were around the Sarasota, Naples, Fort Myers area in 2018 or 19, you'll probably remember this. And even this year in Tampa Bay, the bloom was pretty intense. It stayed in Tampa Bay for a little while, and then it came out that Tampa Bay flushes or exchanges water pretty rapidly. But we still have a bloom ongoing on the west coast of Florida. What I realized with Florida red tide, even though it is a native species and we've gotten a bloom every single year, when these blooms get close enough to shore, that's when humans play a role, either by our sewage overflows or the fertilizer that we put on our lawn or natural nutrients coming into our coastline, urbanization, rainwater coming down, hitting concrete, bringing all that fertilizer and all those pollutants to our coastal waters and allowing red tide to use that nutrients and grow like crazy. And when red tide is in really high concentrations and killing all those fish, they can actually use the dead fish as further nutrients, basically feeding themselves. And that's why Florida red tide is so problematic and gets so intense. And our contributions can intensify these blooms and sustain them or make them last longer. So during that 2018 bloom, I realized that it was more than the science that needed to be addressed. We needed to teach the public how they impact red tide and to understand how the world works so they can understand the complexities of Florida red tide and how this species is different from other species and starts offshore and all of that. And so I learned some things through teaching my parents about the bottled water and through teaching my friends about throwing trash out their car window and through teaching the public and kids about Florida red tide and kind of taking care of chaos or educating the public long term, I found comes down to three things: teaching people, enhancing scientific literacy or how people understand science and the earth. Next, include people, give people a voice, listen, and give them validation that what they're seeing, their observations and their impact is important. And then empower people to take charge of what they have control of in scientific research. And to do that, following and before that Florida red tide bloom, I redeveloped the beach conditions reporting system, which is a website that allows trained beach sentinels or citizen scientists, now called community scientists, to report conditions at beaches so that the public has that information on hand. We have our Moat Marine Laboratory, because I'm no longer there, I'm now at NOAA. But this website, visitbeaches.org, and it's a smartphone app, has over 40 beaches reporting conditions twice daily so that the public knows exactly what to expect when they go to the beach. This not only helps public health, but also protects tourism, because when someone comes down to Florida and has a bad experience at the beach, they're never going to come back. But if they're told, hey, this beach doesn't have effects of Florida red tide, so you might want to go there instead, we can actually not only protect their health, but also protect tourism. So to add to that, we now have a community science or citizen science reporting app connected to visitbeaches.org, where you can report what you're seeing at the beach. And you can do this from anywhere in the world, and it will be reported on a map that you can see and look at. In addition to that, we got community members involved with getting real quantitative or numerical data for scientific research. So I worked with NOAA and the Gulf of Mexico Coastal Ocean Observing System to develop a cell phone microscope where we taught citizens, volunteers, to take a sample of water, put it underneath a microscope, upload a 30-second video into a smartphone app on the phone on the microscope. And then that app actually calculates the concentration of Florida red tide by shape, size, and movement. So we can get that into a NOAA respiratory irritation model so that people know if they're going to cough or sneeze at a beach with 3 days advance notice. So I realized that with Florida red tide, there had been 70 years of scientific research, and there's still so much we don't know about Florida red tide, and a lot of that is because it's a microscopic, tiny little species in a huge body of water that acts different in a laboratory than it does in the natural environment. because there's so much about the natural environment that we still don't know. So taking samples locally was not getting us where we need to be. So I joined NOAA, not only because I think that kids should be wearing NOAA shirts. Did you know that NOAA actually has more satellites than NASA does? But also because we have all of these problems just in Florida alone, but all over the world, and none of them are actually local. So for Carenia brevis, it's not just a local problem. These blooms are impacted by hurricane events, by Saharan dust, which is dust, sand coming over from Africa, brought over by trade winds in the air, bringing over all this sand to the Amazon, which feeds the Amazon, but also to the Gulf of Mexico, where it feeds another species in the Gulf of Mexico called trichodesmium. It's a cyanobacteria, marine cyanobacteria, that then dies and provides food to Florida red tide on the bottom of the ocean. Isn't that crazy? That's just mind-blowing how everything in this world is connected. In addition to that, ocean currents play a huge role in these blooms. This that you're seeing in orange is the Florida loop current, and depending on where it is each year, it is an indication of how intense of a Florida red tide bloom that we will get. And some scientists hypothesize that 40% of the United States might have something to do with Florida red tide. Did you know that 40% of the United States, I think it's 38 states, all drain to one area in the Gulf of Mexico? And because of all that nutrients from agriculture and wastewater overflows and urbanization and everything else that comes into the Gulf of Mexico, it causes a huge algae bloom. Now, a different species than red tide, but when that algae bloom dies, it uptakes oxygen from the water, causing the second largest dead zone in the world. A dead zone is an area with low oxygen that can harm or kill aquatic life. And last, my friends just found out that it's possible that blue holes in 50 miles off the shore of Florida in the Gulf of Mexico might be contributing to these algae blooms. These blue holes are ancient sinkholes. So when the water level was much lower than what it is today, these sinkholes formed, and now the water level has increased to what it is today, and they act as springs, basically bringing nutrients from the land in Florida out to the Gulf of Mexico and possibly feeding these Florida red tide blooms on the bottom of the ocean. So all of these things coming together and all these data points, how do we connect them? And that's through models, but not these models, these models. And so right now I am the modeling portfolio manager at the National Ocean Service. So basically I manage our United States coastal oceans for the Ocean Service to understand how all of these systems connect together and understand what, and forecast, predict Florida red tide blooms. So my experience growing up in Buffalo near Love Canal led me to education, which led me to Florida red tide, which led me to NOAA. And that's the one thing, as you're growing up and going through your classes, you may or may not end up in science, but it's really important that you follow your heart, you follow your passion, and you always work hard to get where you want to go, because there will be obstacles no matter what. And every single obstacle that you come to, you can overcome if you work hard enough. There's going to be classes that you absolutely hate, especially if you go into engineering, and you just got to get through them, because at the end of the day, your passion, what you're going to do after all of that, is what matters. And just this is the second last slide right before we go. I just wanted to tell you the truth about science. So the truth is, you're going to lose a lot if you go into science. 99% of the time you're going to lose. And that sounds a little scary, but I kind of equate it to video games. If you've ever played a video game where you know the passcode to win, you can pick a transactional job like that where you win every day. You can be a cashier at a store or anything like that, where, you know, every single day you're winning. Or you can go into science where every single day it's like you're playing a new video game, or you're on a new board that you've never seen before. And of course, you're going to lose most of the time, but that 1% of the time that you win, you have the opportunity to change the world, something that you never get from other career paths. And so that's what drives me in science, is discovering things and discovering, you know, our understanding of how everything works in this world to make people's lives better and make animals' lives better too. So even if you don't go into science, and it is important to get you guys involved in science and in engineering, because that's where the jobs are going. But it's more important that no matter what career path you choose, that you have an understanding of how the world works, because that's really what's going to change the world. Having more hairdressers and truck drivers and lawyers and doctors understand Earth systems and making decisions and actions every single day that protects the environment and sustains quality of life for future generations. Any questions?
Thank you so much, Dr. Tracey, for talking us through your journey as a scientist. I think that seeing like how and why you came to this important work is just so exciting to learn about. And we do have some questions. So from Chloe, who's at Family of Christ Tampa, they would like to know, how does red tide affect the body?
Our body? So red tide affects us by blocking off our sodium channels. So it basically makes our nerves fire, and that's why we cough and sneeze. Now, for those with respiratory illnesses, this can be really serious because they don't have the ability to bounce back like we do. And during an intense bloom, people can be sick for a long period of time. Also, Florida red tide has been known to cause skin irritation in the water. Some people have complained of headaches, and some people have actually complained of nausea. Just like anything else, many toxins impact the human body, each individual differently. But in general, that blocking the sodium channels is the most common, that cough that we experience.
Thanks. Yeah, I have asthma, so when red tide is happening, it's tough for me. So for those of you out there that have that happen too, I know how you feel. Another question from Erin, who's at Morningstar School. They're wondering, what can students do, what can kids do to help stop red tide? What practical things can we really do right now? Who should we talk to? What should we be doing?
That's a great question. And the one thing that you can do is not only learn about Florida red tide in water cycles, but also look at your impacts. You know, what are your parents putting on your lawns? You know, are they using fertilizer? Do you have native plant species? Because grass, we all have grass on our lawns, right? Well, grass is not native. And in fact, it's the world's largest agriculture crop and produces nothing. Think about that. Think about all the resources we put into grass that produces absolutely nothing when there's so much world hunger and you know, so much excess fertilizer use, when we have such a beautiful state and so many beautiful native species that we can allow to grow, and it actually improves the aesthetics of your lawn if it's done strategically. So you can do that. You can do something called putting in downspouts and rain barrels. So that's diverting the water from your roof to a rain barrel that then uh, releases into a rain garden or a patch of lawn or whatever it is. And the reason for that is right now, when it rains, that rain falls on your roof and might go down your gutter, down your driveway, into a storm sewer, and right into our natural water bodies. So that's kind of manipulating or changing the natural water cycle. So if you use these downspouts and cisterns where you're keeping the water and the nutrients where it was meant to lie, you're reducing the amount of runoff and the amount of pollutants and nutrients going into our water bodies. So those are some things that you can do right now.
Awesome. Thank you for those suggestions and guidance. We are out of time with you, Dr. Tracey, and we really appreciate the time that you shared. For folks that want to get in touch with Dr. Tracey, there's more information there, and we will be back soon with more St. Pete Science Fest.
Thanks, everyone.